the winter break assignment video help series that I'm going to put together and put on Schoology. This is part one, the hydrocarbons. And hydrocarbons are named that way. It's very, very simple actually, because they contain only carbon and hydrogen. So we name them in that way. Now, one of the first things you want to get down as you're doing this is the set of prefixes that we use. The prefixes tell us how many carbons are in the structure. Now that structure could be what I would term a trunk, the main structure of the molecule, or it could be helpful for naming the branches that come off of that trunk. So you're going to see a lot of these molecules are branched as we go along. So each of these has a numerical meaning. Meth means 1, F means 2, O means 3, Bute means 4, etc., all the way up to dec, which means 10. For the first 4, it's often helpful to use the memory device. Mary Ellen plays bongos. The M stands for Mary, the E for Ellen, the P for plays, and the B for bongos. So we have meth, F, prop, and bute. First 4. And those are very common when we're naming these guys. So that's just a couple of things to keep in mind as we go along there. If you have a branch coming off of the main trunk that's got 2 carbons in it, we would say that is called ethyl. If it's 1 carbon in the branch, it's methyl, etc. Propyl, butyl, pentyl, etc. So just those are some key things to get down. So let's say that we decide to start drawing some of these guys, and we'll look at a couple of examples here. Let's start simple and go with the simplest of the hydrocarbons, which is methane. And you guys know that methane has 1 carbon in it, and it's surrounded by 4 hydrogens. Now, for purposes of this video and for my class, I don't require that you draw the hydrogens when you're doing the expanded. You can just leave the branches out. So let me show you what I mean. You could just draw it like this. We'll assume that there's hydrogens coming off of each of those bonds. Now remember, carbon makes 4 bonds, so we would show 4 surrounding it. On the AP test, I highly suggest and recommend drawing each hydrogen. Don't leave that blank. They may not know what you mean by that or pretend they don't know what you mean. So that would be methyl. We add a carbon to it. We now have ethyl. We add another one. Sorry, we have ethane. We add another one. We have propane, butane, etc. And that forms a chain or a trunk. And this would be butane. The formula for butane is C4H10 in that case. This type of molecule is known as an alkane. And alkanes are single bonds only in the molecule. Okay, so the last portion, that ane, A-N-E, means single bonds. Okay, so this would be, in this case, butane. The ane means single bonds. If we do the condensed for butane, the condensed formula, you take this, which is CH3, and write it as such. You take this, which is CH2. You take this, which is other CH2, write it down. And then you've got the CH3. It would be known as a condensed formula, which is shown in your study guide. This is the expanded. Both are helpful, just depends on what we're doing. I may ask for both or either one of those on the test that you guys will have when you get back. So that would be just naming alkanes in general. Now, if we start adding things to alkanes like branches, that brings in some more things that we have to do. It's not tough, but it's just extra. So let's look at our butane again, which we have here. And let's add a methyl branch to it. If I look at this, we just added the methyl. Now, as far as naming this thing, we want a number. And when you see the branch here, you want to start your numbering from the side that's closest to the branch. So we have 1 here, 2, 3, 4. Okay. You don't have to write the numbers down when you're drawing the structures. That's for you just to kind of figure out where everything's located. And those numbers are locators. They're like the address of the branch. So in this case, we have a methyl group located at the 2 spot. So this would be 2-methyl butane in that case. Very simple structure, 2-methyl butane. Okay, let's get a little more complicated here. You know I like to complicate things. Let's put together a 6-carbon. Remember, 6 is hex, so this hexane chain bond. Remember, single bonds because of the ane. So the C6 looks like H14 just in the trunk. So this would be just regular hexane. Okay. So let's say that we have this group there and another one coming off of there. Okay. If I go to name this thing, we need to count the longest chain of carbons in this for the naming. So we look at this, we have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So no matter how we cut it, this is a hexane branch. They don't have to be in a straight line. They could be bent, you know, at angles like that. But the largest amount of carbons in a row is the trunk. So no matter how we cut this, it's hexane. So I'm going to number from here 1, 2, 3, 4, 5, 6. And off of the second, we have this guy, which you guys know is a carbon with 3 hydrogens, which is CH3. Okay, that's a methyl group. Over here we have 2 carbons. 2 means, or 2 is translated to F. It's a group, a branch coming off of the hexane, so it's ethyl with a YL. So I would name this in this way. We've got the 2 methyl, 3 ethyl, and then we end it with hexane. 2 methyl, 3 ethyl, hexane. And that would be how we name that guy. Okay, on this one, we again have a 6-carbon chain, which is hexane, as you guys know now. You notice on this one, we have 2 methyl groups coming off of it at different spots, and they're right in the middle. And so it becomes this question of, well, where do I start numbering if they're in the middle? And the answer is real simple. It doesn't matter. So we still have our 6. So I'm going to start at the left. 1, 2, 3, 4, 5, 6. Here we have 3 methyl. Here we have a 4 methyl. But we don't usually write 3 methyl, 4 methyl hexane. To save time, what we say is 3, 4, and then there's 2 of them, so we use di-methyl, and then we end it with our trunk, which is hexane. 3, 4, dimethyl hexane would be the name of this guy. Okay, so those are some basics on naming and drawing formulas for the alkanes, the single bonded hydrocarbons, whether they have branches or not.